Hi viewers, welcome to my class on mechanics of materials. In today's class, I'll explain to draw the shear force and bending moment diagram for a cantilever beam subjected to various types of loads. Let us work out an example. So the cantilever beam shown in figure, draw shear force and bending moment diagram. So here the cantilever beam is shown with the fixed end on left side, and it's subjected to a UDL, couple and a point load. Now, when the fixed end is on left side, and since we are finding out the shear force and bending moment from left side, so you have to find out the reactions at the supports first. To begin with, you have to find the reactions at the fixed end. If the free end is shown left side and fixed end is on the right side, you can start the problem directly without getting the reactions. But in this case, we need to find out the reactions first. So to find out the reactions, a fixed end will exert a resisting force and a resisting moment. Since the loads are only vertical, resisting force will be vertical and it will act upward. And there will be a resisting moment. You can always show the resisting moment in the anti-clockwise direction. You can show the resisting moment in the clockwise or anti-clockwise direction, but most of the time the loads will produce a clockwise moment on the beam. So this load is producing a clockwise moment, and this UDL is also producing clockwise moment, and couple is also clockwise in this case. So it's trying to rotate the beam in the clockwise direction. So resisting moment will be in the anti-clockwise direction. So you can directly show the resisting moment in the anti-clockwise direction. And in case if you are getting minus value, that shows it is in opposite direction. So let us find out the reactions at the supports first. So I have shown the resisting force and resisting moment. So resisting force is Ra, let us take it as Ra, and resisting moment is M. Now to find out the resisting force, we need to sum up the forces. So Ra minus this load, that is 20 into 0.5 minus 15 is equal to 0, or you get Ra as 25. So Ra minus 20 into 0.5 minus 15 is equal to 0. That is a net summation. Couple we need not consider in the force summation because the resultant force due to couple is 0. So you get Ra as 25 kilonewton. So we got this reaction. Now to find out the resisting moment produced by the fixed end, we need to go for the moment summation. The moment summation you can do with respect to any point. Let us take the point A as the moment center. Now taking point A as moment center, minus M, since it is anti-clockwise, minus M, this load is 20 into 0.5. It will act at a distance of 0.25 meter from B. From A, 0.5 plus 0.25, 0.75 meter. So the moment of this is 20 into 0.5 into 0.75, and this couple is 20, so plus 20, and again 15 into the distance is 2 meter. So that will give the moment summation. So taking the moment summation with respect to point A, minus M plus 20 into 0.5 load into 0.75 plus 20 clockwise coupled, 15 into total distance 2 meter. The summation is equal to 0, or from that you get M as 57.5. If you are taking clockwise, you will get minus value here. So that means you have to reverse the direction and show. That shows this in the reverse direction. Minus sign doesn't mean that it is anti-clockwise. So here we have taken anti-clockwise already, and you are getting only the numerical value of that resisting moment. Now let us calculate the shear force acting over the beam. Now to calculate the shear force, you can first take the section AB. Okay, section AB. When you look at the forces, this only one force is there, which is 25 kilonewton RA. So the shear force in this section is RA, which is 25 kilonewton. So shear force in the section AB is RA, which is 25 kilonewton. Now for the section BC, you have to take immediately right of B and immediately left of C. So taking this section RA, and there is no further load here. Immediately right of B means no load is added. This is only infinitesimally small. So plus RA, that is 25 only. The shear force right of B, there is no change. It is 25 only. Shear force right of B is 25. When you take shear force left of C, 25 minus this part of load will come. Immediately left of C, the complete load will come. So 20 into 0.5, and it is downward, so minus. So 25 left of C, 25 minus 20 into 0.5, 15 kilonewton. And let us take in the section CD. Section CD, when you move from left of C to section CD, there is no change in shear force because no load is added. So shear force will remain same, 15. So section CD, 25 minus 20 into 0.5, same load, 15 kilonewton. Shear force is same, 15 kilonewton. When you move from section CD to section DE also, there is no change in shear force. Couple will not change the shear force at that point. Couple will not change the shear force. There will not be any change for the shear force for the section DE. So section DE also, you will get the same shear force, 25 minus 20 into 0.5. So that is the shear force for the section DE. We have calculated the shear force for all the sections. Now let us calculate the bending moment at various points. Now, since a couple is acting here, we have to calculate the bending moment left side and right side of point A. So bending moment left of A without considering these couple or forces. So bending moment immediately left of A, bending moment is 0. Bending moment immediately right of A, you have to take the couple, and since the couple is acting anti-clockwise, minus 57.5, and the force will not produce any moment because we are infinitesimally small distance right of A. The distance is negligible, so the moment of this force is 0. So immediately right of A, you will get the bending moment as minus 57.5. So minus 57.5 kilonewton meter is the bending moment immediately right of A. Next at B, the bending moment is minus 57.5, and this force will produce a clockwise moment. So at B, it is minus 57.5 plus 25 into 0.5. Okay, so that will give minus 45 kilonewton meter. Now bending moment at C is, this couple is there, minus 57.5, and 25 will produce a clockwise moment. The distance is 1 meter, so 25 into 1, and this UDL will produce an anti-clockwise moment, 20 into 0.5, that is the load, and it acts at a distance of 0.25, so minus 20 into 0.5 into 0.25, so that is the bending moment at C, minus 57.5 plus 25 into 1 minus 20 into 0.5, the load, into the distance is 0.25, that will give minus 35 kilonewton meter. At D, you need to calculate immediately left side and immediately right side. So immediately left of D without considering the couple. So immediately left of D, let us calculate minus 57.5 plus 25 into 1.5, it's producing clockwise moment. Now this load 20 into 0.5, it is acting at a distance of 0.5 plus 0.25. The resultant load is 0.25 from C. So minus 20 into 0.5 into the distance is 0.75. So minus 57.5, 25 into 1.5 minus 20 into 0.5 the load into the distance is 0.75. So that will give minus 27.5. Now immediately right of D, the change in bending moment is only this couple. We are moving infinitesimally small distance from left side to right side. So the moment due to this force, bending moment due to these forces will remain same. You have to add this couple plus 20. You have to add this couple plus 20. And because it's clockwise, you should add this 20. So bending moment right of D is bending moment left of D. Whatever value you are getting here plus 20, so you will give minus 7.5. That is bending moment immediately right of D. So that means at D there will be a sudden change, minus 7.5 to minus 7.5. At E it has to be 0. If you sum up, you will get 0. Now let us draw the shear force and bending moment diagram for this loading. Shear force in the section AB, it is constant, it is plus 25 kilonewton meter. From right of B to left of C, it is changing from 25 to 15. The UDL downward UDL will always linearly decrease the shear force, and we have calculated right of B and left of C. You can show that variation 25 to 15. And in the section CD and section DE, we got same value 15 kilonewton. So this will not make any change in shear force at that point. So you can draw a horizontal line showing 15 kilonewton for both the sections. And then here you can close it because a downward load will be there. So it will just close the shear force diagram. So this is the shear force diagram for the lane. Now bending moment diagram, left of A bending moment is 0, right of A it is minus 57.5. So immediately at A the bending moment is changing from 0 to minus 57.5. So you have to show that change at A, 0 to minus 57.5. Then at B we got the bending moment as minus 45. And we know when no load is acting between, bending moment will change linearly. Or you can look at the shear force diagram, and shear force is constant, bending moment variation is going to be linear. So you can show it by linear variation, minus 57.5 to minus 45. Now here UDL is acting, so shear force will vary linearly and bending moment has to vary parabolically. And at C we have calculated the bending moment, and bending moment at C is minus 35 kilonewton meter. So here you have minus 45, here you have minus 35. So variation you can show parabolic variation. In parabolic variation, the curve should continuously go up without a peak, because shear force is not changing sign in the section BC. And so the curve should move up, and if you draw a horizontal from this point, all part of the curve should be below this horizontal line, and this concave side should be down. Okay, so you draw the bending moment curve parabolically. You can write down the variation as parabolic variation here to clearly indicate that this is a curve. And then next part, left of D and right of D. In left of D, the bending moment is minus 27.5. So from minus 35 to minus 27.5. So you have to join from C to left of D. So minus 35 to minus 27.5. Don't directly join from minus 35 to minus 7.5. Because right of D is minus 7.5. So you have to join to left of D, minus 35 to minus 27.5, and right of D it is minus 7.5. So that change will happen at that point D, minus 27.5 to minus 7.5. That is the effect of couple. couple will suddenly change the bending moment at that point. At E it is 0, and since the shear force is constant, bending moment variation is linear. So this part is a straight line. No load is acting here, only couple is acting, so that will make only changes in bending moment, a sudden change in bending moment. That completes the shear force and bending moment diagram. And we have the maximum shear force 25 kilonewton on the beam, and that will act at A, and also we have maximum bending moment 57.5. Okay, and even that is at the fixed end. So maximum shear force and maximum bending moment is acting at the fixed end. In most of the cases, that will be at the fixed end, unless you have a drastic change due to a couple or something like. So most of the beams, cantilever beams, the maximum bending moment will be acting at the fixed end. That's all for today. Thank you for watching.